Hello everyone, in this video we are going to solve problem 13 of chapter 5. Determine the reactions at the supports. So we have two supports, we're going to find the reaction. But we have distributed loading, so first we need to find the resultant force or equivalent point load of this distributed loading to solve the problem. So first we're going to find the distributed loading. So I'm going to combine finding the distributed loading and drawing my free body diagram. So if this is my free body diagram, I have two distributed loading. You can divide the distributed loading in any way you want to find the resultant force. I'm going to divide it into a rectangle, this rectangle, and then also this triangle. That makes it easier for me to find the resultant force. For that rectangle is uniform, so there would be a resultant force. I call it FR1. It's a rectangle, the magnitude is 600, and the distance is 3 plus 3 would be 6, and it's acting in the middle, so 3 meter. And for my rectangle, I call it FR2, is acting 1/3 of this dimension, so that would be 1 meter from this side, 1/3 from the right side, from the right angle. And the magnitude of FR2, let me write it here. So this distance is 300 because this distance is 600 and the total is 900. So 300 multiplied by 3 divided by 2. That's the most common mistake I see in exams, that students don't divide it by 2, they forget, and the error would propagate. So 450 Newton, and this one is 3600. These are the two forces. Now I need to write my reaction forces. At A, it's a roller, so only AY is free to move in X direction. For B, I have both. I have both BY and BX. You could write BX in any direction that you want. Here my coordinate, the problem doesn't have a coordinate, so I can draw my own. This is XY. So I have 3 unknown, AY, BY, and BX. And I have 3 equilibrium equations. Summation of forces in X equals 0. I have BX. What else? Nothing else. So BX is 0. Then I can write summation of forces in Y, but you can see I have AY and BY, so I'm going to end up with 2 unknown and 1 equation. Let's write summation of moment, and you could choose any point here. So let's choose point A. Summation of moment about point A should be 0, counterclockwise positive. FR2 is going to create a clockwise moment. So this force clockwise moment, this force clockwise, only BY is going to create counterclockwise. So these two are going to be negative moments and this will be positive moment. And I'm only going to have 3 components in my moment. Force FR2, FR1, and BY are going to create moment. So FR2 is 450. Moment arm, only 1 meter. Then the second one is FR1, 3600, moment arm is 3. BY, create a positive moment, moment arm 6 equals 0. I have 1 unknown, so BY is 1875 Newton. Now that I found BY, I can write summation of forces in Y and find AY, the other unknown, or I can write a moment equation about B and find AY, whatever you are more comfortable with. If you solve more problem, then you will have a vision of which one to use, which one is easier for you. So the trick is solving many problems. So summation of forces in Y equals 0. Let's see what forces we have. We have AY plus BY, and then all the other forces. I have 45, near 450, and 3600. So that would be 4050 Newton. I found by here, so the only unknown would be ay. That would be 2175 newton. So 3 equation, 3 unknowns. So this problem combine the distributed loading problem with finding the reaction force. Again, you should be familiar with this support, saying that okay, this is pinned and this is a roller.